Welcome everyone. Today we will be discussing certain problems and programs related to graph data structure. The first problem is called as stepping number. The problem statement is given as follows. A number is called as stepping number if all adjacent digits have an absolute difference of 1. So it is a straightforward approach where we need to identify a stepping number. A number can be called as a stepping number if all the adjacent digits have absolute difference of 1. Say for example 3, 2, 1. Definitely it is a stepping number, as you know the absolute difference of the adjacent numbers whichever you take, definitely it is only 1 as an answer, but that is not the case for an example like 4, 2, 1. So adjacent digits should have absolute difference of 1. You call it as a stepping number. So the problem here is we are given two integers, say n and m, a starting number and an ending number. You call it as a range. We have been given a range. We need to find the count of all the stepping numbers in the given input. Maybe the input will be values of n and m, and the output is the number of stepping numbers. I hope this one will be very much understandable. N equal to 0 and m equal to 21. The meaning is that we need to give a range of values starting with 0 and ending with 21. The output here is 13. Meaning is there are 13 stepping numbers that has been identified between the range 0 and 21. You can see here it starts with 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All individual values. Along with that, you can see here 1, 0 is a stepping number. Basically, you know that all the adjacent digits, absolute value of such digits remains 1. Similarly, 1, 2. Similarly, 2, 1. So these are all the possible numbers. You can call it as a stepping numbers in the range of 0 to 21. That is very important. When I count how much number of such stepping numbers, 13 is my total count value. So this is the so-called problem definition that has been given. Alright. There are many ways you can solve this problem. To identify the so-called stepping number, I repeat here, having given numbers. A number is called a stepping number if all the adjacent digits can have an absolute difference of 1. Such numbers can be called as stepping numbers. So basically, if it is a range between say 0 to 21, you know that the numbers, the possible stepping numbers are listed here. As because the range stops with 21, only those allowable stepping numbers have been taken up. Only these numbers can be called as the required stepping numbers. Now you can go with approaches like brute force, where you try every possibility of the numbers of a given digit. Try to compare the previous and the current digit. Try to find out whether the absolute value remains in 1. If so, you include it. If not, you exclude that, and find the number of such numbers. You call that as your stepping numbers, and find the count. That becomes the answer. A simple brute force approach itself is possible. Possibly, if you think about a better time complexity, a better algorithm, then you need to go beyond the brute force approach really. there might be a chance that for this sort of a problem you can apply BFS and DFS sort of a concept, where you can easily identify the stepping numbers in a given range. The concept behind such a search or a graph data structure is that you can easily find the stepping number, say for example V from U, basically under a graph theory. It depends on something called the last digit. Adjacent number V, with respect to U, the adjacent number can be U into 10 plus last digit plus 1. That might be one neighbor. U into 10 plus last digit minus 1. That might be a neighbor B. Here the way is that if you can apply, say for example, I am telling there is a value 1 that comes here. What might be the so-called stepping numbers, really possible stepping numbers? If you can see here, you can either go with 1 with 0. That is also a possibility, because your absolute values of your neighboring adjacent values becomes 1. So another possibility is 1 with 2. So when I take 1, I need to get definitely the combinations which are all possible for 1 is 1 with 0 or 1 with 2. So here the thing is that once that need to be calculated, a simple logic here is, if my value is 1, my input value is 1, if I can give it here, what happens is that 1 into 10 plus last digit remains again 1, so it is 10 plus 1 plus 1, either 12 might be a neighbor. And another thing is 1 into 10 plus, for 1 the last digit also 1, so it is 10 plus 1 minus 1. What happens is that the answer is 10. So either 12 or 10 might be an answer here with respect to 1. So similarly we need to explore all the possible numbers that comes in the range and try to find out the stepping numbers, really. So to apply a DFS, something like a DFS, you can exclusively apply a breadth first search by applying a Q concept, or even you can apply a depth first search by continuously recursively you are trying to call the same function and try to find out the answers, really. So here the very important thing is get the last digit of the currently visited stepping number. If you have a number, try to get the last digit. Possibly that last digit can be recovered or obtained by mod function. Then there will be only two cases. There are only two cases you can easily identify. Either the digit to be appended is last digit plus 1 or last digit minus 1. That is what given here, last digit plus 1 or last digit minus 1. For any of the number that is coming in the flow, you can take it and you can make sure that whether it is called as a stepping number or not. So this condition becomes very important. The two cases, the digit to be appended, the digit to be appended is last digit plus 1 or last digit minus 1. Say for example, the real case is here. Maybe if I am taking 1, you know that it is 1 into 10 plus 1 plus 1, so it is 12, or it remains in 10. So for 1 it is either 10 or a 12. So those possible stepping numbers can be easily identified. So what happens if a last digit is 0? Then you know that if the last digit is 0, then the only possible digit after 0 can be 1. So that's a trivial case here. Similarly, if a last digit is 9, then the only possible digit after 9 can be only 8. So those are all two exclusive cases here. Otherwise, if these cases are not applicable, you can easily apply your DFS with respect to step number A or a step number B. Here step number A means the last digit plus 1, or the step number B where you give a last digit minus 1, right? Then how to implement it? As I told you, you can implement in variety of approaches. Brute force is one basic concept you can apply. You can go for a BFS or a DFS. There are some advanced algorithmic problem solving strategies which can also be applied to the same problem. Something like a dynamic programming approach can also be obtained, can also be applied and your answers can be fetched with better time efficiency. So we will go with a typical implementation that applies your DFS for this particular problem. As I told you, uh, we'll start with the main function. You get the value of n and m. I have already told you that n and m are the ranges. Say for example, uh, n value is 0 and m value is 21. Between the range of 0 to 21, identifying the stepping numbers, these are all the possible stepping numbers, and the count or the number of stepping numbers present in this range 0 to 21 is 13, right? So now in your main function you get the value of n and m, and you are passing it to a function, say display setting numbers. So here the display setting numbers, really what it happens is that for individually it will start and it will try to get the all those components to be connected with respect to a recursive call here, DFS of n comma m comma I. So here it actually passes to your the function here which you have written for your DFS. It's a very straightforward code where you can easily understand the logic. So if the step number is less than or equal to m, the upper range, or the step number is greater than or equal to n, simply we are able to print the value. Or if the step number is 0 or it goes beyond the range, you are able to return it. Else, I think this is very important. So last digit, through a mod function, you try to track those last digit, and you can see here step num a is equated to step num into 10 plus last digit minus 1. Similarly, you go for the other case. So last digit minus 1 and last digit plus 1. As I told you, if the value is 1 here, you know that it is 10 plus this becomes 0, really 1 minus 1. So the answer is 10, whereas here it is 1 into 10, 10 plus 2, you get 12. So 10 and 12 are the two values for the value 1, the neighboring values, which actually goes in a you can call that as a stepping numbers, really. So that you can calculate it. And of course the trivial cases, if last digit is 0, you simply call the recursively with respect to num b, or if the last digit is equal to 9, as you know that, you can call it your step num a. The thing is, it is nothing but this is what I am trying to explain here is, if the last digit is 0, then the only possible digit after 0 can be 1 for a stepping number. Similarly, if a last digit is 9, then only possible digit after 9 can be 8. So that has been implemented as a code here. Otherwise, I simply call the DFS with respect to A and with respect to B. So when I do this, definitely I able to get the answer for this problem. My stepping number range can be easily identified. So before going into the next problem, possibly I will show the code now itself. Working of the code. Yeah. So this is my code. As you can see, we are calling with respect to both the ranges of n and m. What I am trying to do is that a recursive call of your DFS, where my last digit is updated as a step num mod 10. Accordingly, with respect to last digit minus 1 and last digit plus 1, my step number has been updated, and what happens is that recursively I am trying to call it again and again to get a result. When I run this problem, so I am able to give the range 0 followed by 21. You can see here, these are all the step numbers that has been identified: 0, 1, then 1, 0, 1, 2, then for 2 it is 2, 1, then 3, 4, 5, 6, 7, 8, 9. If you can add all these values, count value will be 13. So this is how you need to identify your step numbers. So the range here is 0 to 21. So if it is beyond that range, possibly you can see here for 3 you can even identify 3 with 2 is a possibility, a definite possibility which you can make. So that those things you need to check out with respect to the range what you are trying to give, so that your absolute difference of your adjacent values or nearby values remains 1. Accordingly you need to fetch those values. For a range of 0 to 21, these are all the possible step numbers you can identify. I will show you another sort of an implementation for the same problem, maybe without using a recursive or a DFS sort of an approach. What you can do is that simply get the range of values start and stop, and by using a for loop and by using an iterative procedure, again you will be applying your mod function to gather your so-called the last digit, and try to find out through a conditional checking. You try to do a recursive call where if it is a stepping number identified, that will come in this region where after your so-called processing, the flag will be all your flags will be set as 0 for those values which forms a stepping number. Otherwise, the other case where if it is not a stepping number, this will go in really according to a condition which we are giving, again rem minus 1 or a rem plus 1, which I have been explaining quite a while now. So there the flag is set as flag gets incremented. So those values where it comes inside this loop becomes a non-stepping numbers really. So those stepping numbers will be identified and it has been placed here, and the count value is given just to count the number of stepping numbers. This is also possible. An iterative approach can also be done, but when you think about better efficiency, you need to go for better algorithmic prospect like BFS, DFS, or even something like a dynamic programming. Maybe I will show you the running of this code as well. Yeah, I'm giving 0 followed by 21 as my range. You can see here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 1, 0, 1, 2 and 2, 1. These are all the possible step numbers, and the count of those step numbers will be 13. There are 13 step numbers available between 0 to 21. So this is also equally possible while you are implementing it in a different approach. Now we will go into the from the next problem. You call it as a moon journey, right? The problem statement goes in this way: the member states of the UN are planning to send 2 people to the moon. They want them to be from different countries. You will be given a list of pairs of astronaut IDs. Each pair is made of astronauts from the same country. So determine how many pairs of astronauts from different countries they can choose from. You need to understand this problem very clearly. So there is a plan to send people to the moon. They want them to be from different countries. So they need to fetch the combination or the pair from different countries. So you will be given a list of pairs. Each pair is made of astronauts from the same country. So how many pairs from different countries can be chosen? So that is what you need to identify. Say probably you will get a hold of this problem by seeing the example. Say for example, the data on 2 pair of astronauts. There are 2 pair of astronauts and 4 astronauts in total. Really, there are 4 astronauts in total, in the range of 0 through 3. So basically 0, 1, 2, 3 are the 4 astronauts available. Now there are 2 pairs already given. Pair you can see here 1, 2 and 2, 3. So astronauts by country. So if it is 1 and 2 and 2 and 3, you know that really the 1, 2 and 3 basically forms from the same country. 0, which is not at all there paired here, so that becomes a separate. So which means I have a set 0 and a set 1, 2, 3. How much number of combinations? You know that 0 with 1, 0 with 2 and 0 with 3 can be done here. So there are 3 pairs you can do that. So that is what the answer they are requiring. I will go with even more a better example than this so that you can have a clear understanding. You can see here, this is how the problem is. 5, 3 is an input that has been given, where I say 5 is nothing but the number of astronauts. 5 is nothing but the number of astronauts. So the astronauts numbers have been given as 0, 1, 2, 3 and 4. For 5 astronauts, starting with 0 ends with 4. Then you know that there is something like after your so-called the number of astronauts, the pairing has been given really. So you can see here 0 with 1, 2 with 3, 0 with 4. So if you can see here, 0 paired with 1, 0 paired with 4. So basically 0, 1 and 4 are from the same country. 0 with 1, 0 with 4. The so-called inference from that pairing is 0, 1, 4 all belongs to one country. 2 with 3 is a separate pair, so that belongs to another country. So if I have 0, 1, 4 as one group where it belongs to one country, the astronomers belong to the same country. 2, 3 is a separate one where it belongs to another country. Now this is the grouping I have. How much number of pairs I can choose, because I need to choose only a pair with people with two different countries. So here the combinations 0, 2, 0, 3, then 1, 2, 1, 3, and then 4, 2 and 4, 3. So totally 6 possibilities are there. I hope you understand the problem here very clearly. 5 is nothing but number of astronomers available. They will be going to the moon. Their numbers are 0, 1, 2, 3 and 4. And 3 is nothing but number of pairs which is given as input here. The first pair is 0, 1, second pair is 2, 3 and third pair is 0, 4. Having given these pair, you can understand really 0 with 1, 0 with 4. So basically 0, 1, 4 belongs to one country. 2, 3 belongs to another country. So if I am having a grouping of that nature, 0, 1, 4 as one country, 2, 3 as another country, the number of possible combinations, 6 possible combinations like this: 0, 2, 0, 3, 1, 2, 1, 3 and 4, 2, 4, 3. These are all the 6 possible combination I can make those pair to move or travel to the moon really. So how to do this particular problem? It's a very important and an interesting problem. So here the problem statement is that there are some astronomers. Every astronaut belong to a country. 2 astronauts might share a same country. We have to make pairs of astronauts to send them to the moon. Maximum number of pairs possible is what the question that has been asked. So I will go with some diagrams so that you will easily understand the problem. So for this problem, if you can see, the so-called 5 astronomers in a grouping 0, 1, 2, 3 and 0, 4. So 0, 1, 4 belong to one country. So basically 0, 1 and 4 astronomers belong to one country. Maybe this grouping has been formed by the individual grouping like 0, 1 and 0, 4. Initially it was 0, 1 these two, and then 0, 4. So that combines to form one major grouping where 0, 1 and 4 belongs to one country. Similarly, another grouping has been given which is 2, 3, an exclusive separate one. So that 2, 3 forms another grouping really. So because of this grouping, that there are 6 possible combinations you can get, so that in each group or in a pair you get 2 different astronomers of different countries. So that is possible really. So remember this output really. Maybe we will take up this input and output for our understanding, and we will go 5 astronomers, 3 pairs, 0, 1, 2, 3, 0, 4. So basically 0, 1, 4 belong to one country, 2, 3 belongs to another country. If that is the case, there are 6 possible pair which can be formed. All right. Now to make a better understanding, this problem can be solved in 2 different ways. One is basically you can go for disjoint set sort of a data structure where you can apply concepts of your find union algorithm, which is also a prominent method that is applied and deployed in data structure problem solving. So one is your find union or a disjoint set data structure. Another one is maybe you can go for a depth first search. Once again, a DFS concept can also be applied to this problem. We will go with one method, say DFS sort of a solving for this particular problem. There is a logic to be understood here. I will let you know. Say for example, an astronaut in a country is an element in a set. You assume that an astronaut in a country is nothing but an element in a set. Now what happens is that there are two sets. You assume that there are two sets, say A equal to A1, A2, A3 and B equal to B1, B2. Now the answer here is possibly the number of thing which we are trying to explore here, the elements of A into elements of B. So it is A into B. You know that there are three elements in A and there are two elements in B. So my answer is 3 into 2, 6. Say assume that there is a third set along with your A and B set, which has 3 elements and 2 elements. Now there is another set called C, which contains again a 3 element. Here as usual the answer you can fetch here is A into B plus B into C plus A into C. I'm rewriting that. I'm just rearranging this form A into B plus B into C plus A into C as A into B plus A plus B into C. I can rearrange something like this: A into B plus A plus B into C. That can be done. If say for example from here you think about another set, say fourth set, I already have A, B and C. Now another set called D comes in. So if you want to have an answer, you know that it is A into B plus B into C, plus A into C plus A into D, plus B into D plus C into D. If that is done, really again if I can rearrange that, you can see here A into B plus A plus B into C plus A plus B plus C into D. This can be written like this. So if you can see the so-called answers for 2 set or a 3 set or a 4 set, 2 set you can see here you get A cross B. For third set inclusion I get A cross B plus A plus B into C. Similarly for the another set inclusion you can see here A cross B plus A into B into A plus B into C plus A plus B plus C into D. You can identify a pattern from here. Previous answer can be term can be related with your next term, and this term can be related to the next term, and similarly it goes on. So here the new answer here is maybe the pattern you can fetch from this is new answer can be given as old answer. If you can see from this compared to this one, A into B becomes your old answer really, plus sum of old values. Old values is A and B. I am summing it now, A plus B into the new value. The same can be applied here. You can see here A into B plus A plus B into C, which is already there in the previous one. This becomes my old answer here, plus sum of old values, all those old values A plus B plus C into my new value here is D. So I can relate it here, old answer plus sum of old values into new value gives my new answer. This property, or rather this relation, can be exploited for this particular problem to be solved. Maybe I can tell you how your astronauts and the problem of making it to the moon with respect to the pairs can be done. See, assume that you have, again you just think about the problem here, the input 5 astronauts, 3 pairs 0 1 2 3 0 4. So 0 1 4 becomes one country, 2 3 becomes another one. That is what the diagram says. So you can see here each astronomer can be assumed as nodes. Now it's a graph theory where you assume everything every astronomer as a node. So 0 1 4, you can see here 0 1 4, and then the other pair is 2 comma 3. Now I have an updation of values like value, previous value, and answer. These are all the values to be updated. As you know, old answer, sum of old value into new value added to form the new answer. Now what happens is that initially you will go with one particular node, explore this particular node. Say for example, as because it is the first node you are taking up, your value can be changed to 1. Value becomes 1 if I explore this node. When I go with an adjacent node which is unvisited, possibly 4, now the value updates to 2 really. So similarly, when I go with the third node here, possibly here my astronomer 0, my value becomes 3. You can see here my value gets updated accordingly, value becomes 3, no change in the previous value and answer. Now when I reach this, you know that these so-called nodes that are connected have been explored properly. Now we are at the end of a middle session really, which means now I don't have any adjacent node for exploring. So for now I try to evaluate the result. I am trying to update the variables, all those previous answer as well as my previous value. As of now, you know, here the relation is that new answer equal to old answer plus sum of old value into new value. So basically my previous value stands 0. So here my value is 3. So as of now my answer remains 0. After that, when I do my updation for my previous value can be nothing but my I add up with my the actual value right now what I have. So now that it becomes 3. So basically my previous value becomes 3, but answer still remains 0 at the end of processing these nodes. Now my previous value is 3. Accordingly, I start a fresh node now, which is unvisited. Now what happens is that now I will accumulate my value once again starting from 0 really. So what happens is that now it is once I process this node, my value becomes 1, and I process the other node, adjacent node as well, my value becomes 2. Now you can see here I am at the end. Now there is no node to visit hereafter, so I am at the end of the process. I am trying to evaluate the answer can be evaluated like old answer plus sum of old value into new value. So you can see here by applying that logic, what happens is that my value becomes, answer becomes 6, my previous value becomes 3 plus another 2 values. So 5 is my previous value, answer fetched is 2 into 3. My 6 answer actually accumulates in my answer variable. So this is how this problem really moves while we are trying to code. I will show you how it really works here. Right, we'll go with my main function. Initially what I am trying to do is that required variables will be inputted, say n comma m. Here you understand n and m are nothing but the values of yes, so 5 astronomers and 3 pairs given really. So that can be inputted here in the problem. What happens is that once that has been inputted, I will try to declare a Boolean array where the nodes or visited nodes need to be taken care of. Once that has been done, I am trying to what I mean to do is that once that declaration of that array is done, if the node is not visited, you can see here, if the node is not visited, what I can do is that I can start my DFS. I just call my recursive DFS here. So you continue normally. What happens is that once that DFS has been started, that functionality will go into something like DFS function which I have written separately. Here I mark my node as visited and I continue my DFS from the current node, and I always update my value. You can see here the value field is updated here. So this is how I really approach this particular problem. So once that has been done, once the DFS for one connected graph, here the one connected graph, the meaning is that this one 1 4 and 0, once this has been finished, I need to update my values. Variables need to be updated. Here you can see here, once that has been done, here my values need to be updated. Here you can see here answer equal to answer plus previous value into value. This is what we are speaking here. As I told you, according to the pattern, old answer plus sum of old values into new value has been done here. So I am accumulating my answer and I am updating my previous value here. So at the end of my first connected graph, what happens is that my answer will be remaining as 0, whereas my previous value will be assigned as 3. As I told you, you can see here, once initially value 1, once I explore this node, it becomes 1. Now it is 2. This is 3. Yeah, this is what happened. After processing, what happens is that at the end of my one connected graph, my updation of values for my previous value and answer remains 0, but previous value after that, what happens is that it takes the value of 3. You know why? This is what happens here. Yeah, my answer remains 0, whereas previous value added with value to form the previous value, so the previous value becomes 3. Again the value is set to 0. So once that has been done, now what happens is that again it will go with and it will try to fetch the DFS components, and the recursive call will be done. And when that has been done, these two nodes will be taken care of and it will be visited. Accordingly, my previous value and answer will be updated. Once that has been finished, you know that your answer value will be 6, and once that value has been taken up, it will come out and print the answer. Where for this particular problem, your answer is nothing but 6. 6 different combination of pairs can be allowed to visit the moon. So that is a very important thing to be noted here. So the how we are doing this by applying this logic is very important. So here you need to understand that there is something like memset that has been used here in C++. It's a sets. It's a nothing but a block of memory that has been mapped to a single value. Other than that, I think it is very simple. As I can repeat it, you start with declaring the variables here. Once that has been variables have been declared and input has been given, declare a bool array relay. So this is nothing but the matrix, the adjacency matrix of your graph which you are trying to get in. Once that has been done, you try to create or declare a bool array with respect to the nodes that are visited, and if the nodes are not visited, you try to call up a DFS here. You start a DFS. Once that has been called, you can see here that's a function which I have written at the start. In the DFS function, you make that node as a visited one and continue the DFS from the current node and try to update the count value. If that has been done, you can see here, once that is finished, at the end of one connected graph, your answer and previous value will be updated and the value is set to 0. Again it will go off and it will finish off until there is no node to be visited or no node is present. When that case comes in, it will come out and it will try to print the answer value. So this is how this program really works. Maybe I will show you how it really runs here. The moon problem which I have shown here, you can see here. So this is how it does. In your main function, you get the input, try to make a DFS call with respect to the nodes and try to update your answer and previous value here. Under your DFS function, you simply make the node as visited and try to go and dig deeper into those nodes so that you apply a DFS to the neighboring nodes here. So when you do that, value will be updated as usual, and once the one connected graph is over, your answer and previous value will be updated, and it will be done as long as there is a node to be visited. Once that has been finished, it will come out and it will try to print the answer really. So this is how your this program really works. If I can show you how it really runs here. Yeah, I will run it again in a different name. I will keep it as moon program. Yeah, now what it is showing is that I have to give how much number of astronauts, 5, how much number of pair, 3. I give the same input really so that it will be helpful. 0 and 1 is one pair, then 2 and 3 is another pair, 0 and 4 is another pair. So these are all the three pairs: 0 comma 1, 2 comma 3 and 0 comma 4, as I have explained throughout the problem. So 0, 1 and 4 becomes astronauts from same country. 2 comma 3 is another pair with the different country. So to make a pairs out of that, different country people, to make a pair, there are 6 combinations really. So my answer should be 6. So this is what the answer. 6 is nothing but the number of pairs really, as I am telling here. Yeah, this is what the meaning here. The 6 is nothing but an answer like 0, 1, 4 and 2, 3 forms 2 separate groups. So the 6 different pairs are 0, 2, 0, 3, 1, 2, 1, 3, 4, 2 and 4, 3. This is what the answer really obtained for this particular program. So today we have seen two problems. One is with respect to stepping number, another one is with respect to how we can really formulate the problem so that the pairs of astronauts can be combined, and according to the combination, how much number of combinations can be possible according to the problem statement given. Both the problems have been done and executed today. So I hope you enjoyed this session, and we will meet you for the next session shortly. Thank you.